6?
Yes, sir.
Okay. So let me start with the predicate logic, which is very essential for our lab sessions also. Today we have a lab, and in lab CSI will not be there. In lab I will be there, and SMSI will be there. And so I am starting with the lab related portion, that is lab related theoretical portion, and then I will go to the theoretical portion, which I will be covering. So today, let me tell you about predicate logic. Now, we have already gone through the propositional logic in discrete math. In most probably in discrete math. In discrete math paper, you have already gone through the propositional logic.
Yes,
Have
sir.
you gone through it? Okay. So let me recap those the basics of propositional logic. Then I will enter into the predicate logic. A number of similarities are there in between these two, proposition and predicate logic, as well as dissimilarities are also there. Or rather, I must say that definitely propositional predicate logic is much more advantageous than that of the propositional logic. We will see that how it is better, how predicate logic is better than that of the propositional logic. So let me recap propositional logic. Now, in propositional logic, what we have learned, that is a statement. Basically, we will not take the term sentence. We'll always use the term statement. Now, in propositional logic, you have learned, I think, that is a statement may be represented by a capital letter. Now, if I am taking an example, that is Ram is a student, or maybe Rahul is a student of HETC, then I may represent the whole statement. Again, I'm telling you, I'm not telling you that this one is a sentence. It will be better to say that it's a statement. Now, Ram is a student of HETC. If I'm saying that Ram is a student of HETC, now that may be represented by any capital letter. Now, normally we are using maybe student, so it may be represented by S, capital S, then colon. Ram is a student of HETC. Or if you are taking R, that is the name starting with R, then I may represent the proposition as R colon Ram is a student of HTC, or it may be with some other letter, normally capital letter. Now the limitation of propositional logic is here you cannot show the relationship or the functionalities within the statement. That is just like student. I may say that student is the student or studentship is the relationship between Ram and HTC. So Ram and HTC are the two entities, and studentship or studenthood may be the relationship or the functionalities here in between these two entities, that is Ram and HTC. So that cannot be represented by a single letter. Now that is that particular functionality or relationship may be established by using predicate logic. So that is the advantage of predicate logic. Now I may represent that is, that is I may represent the statement using predicate logic like this one. Okay, let me show. Now if I'm taking this one, like if I'm saying that AS in propositional logic, AS is nothing but that Ram is a student of HETC, then it may be represented in predicate logic as AS, then that is Ram, the name will come first, Ram, and then HETC. Now, or I may say that not writing is, I may write student also here. Okay, so writing only is, or it may also be presented by student. Normally we have used a capital letter only, not writing student or STU or ST in propositional logic. It's much more better representation in predicate logic that is student or s, then within bracket ram comma HTC. So it's this one is much more meaningful than that of the previous one. Are you agree or not? Then I'll come to the next part. Or it may be represented. It may okay. Let me tell you in from functional point of view. If I am representing student as f and ram as x and HTC as y, then I may say that f is the function of x and y, or I may say that f is the relation of x and y. Now, what is the relationship between ram and HTC? The relationship is the student or studency, and so similarly, I may say that f is the relationship between x and y. Now, is it clear to you or not? Just like in mathematics, what you have learned about function. So here also, you may take all the representation, or most of the representation you will get in predicate logic with functional representation. That is a function name or relation name will be there, and that will be applicable on the arguments of the parameters written within the first bracket. And all the arguments or parameters or attributes are separated by a comma. So that is the fundamental representational difference, as well as there is clarity in understanding about a statement. Now, after this, any question? And have you got the difference between predicate and proposition? If any doubt, then ask me. So no question. Just hold it. So have you got it or not? Now let me go to the newer part. So let me tell you about the the operators we are going to use in predicate logic. But before going to the operators, let me again brush up, or let me again remind you the key points. That is, when you are representing a statement using a predicate logic, always the arguments, that is on which, or entities on which the relationship or functionalities will be bound, must be enclosed within a pair of first bracket. All the parameters or attributes must be separated by a comma, and the first letter normally written with a capital letter, that is the first letter of the entity or attribute name. And again, that is the predicate name. This one is sometimes called the predicate name also. Relation name or functionalities name, or sometimes it's called the predicate name. The predicate name also may be written in abbreviated way, like S or STU or ST, or it may be written fully, that is a student. Okay. Now, it may be represented by a small letter or capital letter, the first letter. But in arguments, the first letters are normally coming with a first letter at the beginning, capital letter at the beginning, then the other letters may be in capital or small. Now, if it is a numeric value, then simply you have to write the numeric values like 12, like this. So no need to write the character or string values with single quote, double quote, all these things, the attribute values. Okay, you may simply write these in a way like this, RAM, HTC, 12, in that way. And similarly, the predicate name also. You may use underscore also. You may use like roll underscore 12. So this may be a valid attribute or valid properties if you are using here within the pair of first bracket, if somewhere it is required. So underscore is allowed, but no space will be there in the values, and all must be separated by comma. Now, there may be some predicate not with any attribute. So that is also possible. So I may write is, then bracket open, bracket close, no problem. And also it may be with more than two arguments also. So that depends upon the statements, that depends upon the given statement, that is, which is being converted to a predicate representation. So I may say this one is the given statement and this one is the predicate representation of that particular statement. Now let me go to the operator part. And one more thing, that is these is in sometimes in some
That
books.
screen is not clear, sir.
Which one? That is
Sir,
ठीक है,
picture
that
is
is
clear.
Nothing is clear on the screen.
ठीक है, clear আছে না? Okay, एक minute. एक minute. Back camera. Switch camera. Now look at this one. Is it visible? Is it visible? Now is it visible?
No, sir.
Still now it's not visible. No, that is Ram is a student of HTC. That is not visible. The statement written within a rectangle at the top.
No, sir. No, sir. It's all hazy.
So hazy. Okay, wait. Now is it visible or not?
No, sir. No, sir.
Look,
Sir, the
okay, let
camera
me
can't
zoom.
focus due to inadequate light.
Camera? Inadequate light because maybe. Okay,
Sir,
let
you
me
have
just.
put the camera too near to the page. That's why it's not visible, sir.
Okay, just wait. Wait, I'm moving to different location. Now is it visible?
No, sir.
Still
Yes,
not.
yes.
So how can
Sir,
I
don't
show you?
take the camera too near, sir. You can't focus on the page. Yes, sir, it's visible now.
Now it's visible. Okay. Now, okay. Look at the top of the page. A student is written there. Or let me write it again. Let me write it again. So what I have taken as example, like if Ace is being used to represent the statement Ram is a student of HETC. Okay. Now, if it is in predicate logic, then I may represent the sorry. If it is in preposition logic, then I may represent the same thing in predicate logic like Ace, then within bracket Ram, comma HETC. Okay. So this one is the predicate representation. This one is the propositional representation. Okay, so it's not needed. This particular portion is not needed to be written always after that is giving a colon here. You may simply write S, which is the representation of Ram is a student of HGC. You may write this one for Ram is a student of HGC. Now the difference is that is here Ram and HGC is addition to S. So that means here only S is not there, but it is working as the relationship or functionalities on RAM and HGC. That is, this is the relationship between RAM and HGC, or this is the functionality between RAM and HGC, just like a mathematical function f x comma y. So it is the function of x comma y, or I may say f is the relation of x and y. Okay. So that particular representational difference is there, and that particular representational difference itself is giving you the inner details of the statement than that of the representation in propositional logic, where only single symbol is being used, and that is not giving you the inner details, only S. Now what I have told you, that is S may be written as not writing simply S, I may write student also. I may write STU. So that is up to you. That is how much you want to write, or not writing RAM also I may write R, or not writing HGC I may write H. Normally the attributes which are being used RAM, HGC, normally they are simply being taken from the statement itself. Now if you are following the same thing for the name of the predicate, this one is for the name of the predicate, this is, then it's better to follow student, not writing S. So I think it will be better for this statement, it will be better to represent using predicate logic like student, then within bracket RAM, comma HTC. Now look at this one and this one, and the encircled portion RAM, HTC, HTC, student, student. So here, if you are looking at the statement, just this one is your relationship student or the functionalities in between RAM and HTC. Okay. Now that is not represented in propositional logic. And what I told you, that always remember the representation. That is always that is on which the relationship should be applied, or the functionality should be applied, must be enclosed within a pair of first bracket, and the arguments are taken from the statement RAM HGC. Okay. Normally the first letter are in capital, and here normally the first letter are in. Okay, one more to admit. So normally this is being one more thing. Okay, normally it is being taken from the statement, but you may represent in a way like this: student, then maybe RAM, then HETC. Okay. So different conventions are there. In today's lab, we will see the different convention is being used in Prolog. Okay, and which is following the predicate logic. But according to standard syntax or standard nomenclature of the predicate logic representation, normally this one is being used as like this, not like this one in predicate logic. This one is also like this, not this one. Although these are meaningful, but according to standard predicate logic representation, you must write in that way. Okay. Similarly, whether using small s or capital S, then I think it will be better to use the capital S. This one not going for this one. Okay. In prologue, we'll see the difference in representation. And normally, if you are representing a statement with a ended by a full stop, now you may represent by ending with a full stop or not. That is not a compulsion that you have to put a full stop at the end of the statement, predicate representation statement or predicate representation of the given statement. Okay, any query after this one? No. So let me go to the operator part. So what you have learned in the predicate logic, propositional logic. So this one was for and, agree or not? This one was for or, this one was for not, this one was for implication, this one was for both way implication. Have you gone through all those operators? In discrete math, in predicate propositional logic? And or not, implied, equivalence. This one is nothing but implication or implies, and this one is the both way implication or equivalence. Have you gone through all this?
Yes, sir.
Okay. Now there may be difference. That is, this may be represented by not writing this one in some notation. In some representation, you may get A and D. That is like A and D. But mostly this one is in use. Just like this one also, you may get OR. But normally in most of the cases, you will get this one, not OR. Okay. Similarly, but not may be represented in two different ways. This one, or you may represent using this one also. So not may be written in that way or this way. Now here the additional symbol you have to use, that is this one. These are called quantifiers, this one and this one. I think those who have gone through the graph theory classes in any of the paper, these two symbols are also known to you. This one is there exist and this one is for all. There exist and for all. That is for a single or a specific to identify or to point out a specific item, then we have to use there exist, and for all to generalize we have to use for all. So let me show you an example. Now if I am writing a statement, man is mortal. Okay, if this one is a given statement, then I may write man is mortal with predicate representation as mortal, then within bracket man. So this one is the correct representation in predicate logic. Now this one is okay. Man is mortal. I am writing mortal man. Now, if I am saying that it's a general statement or specific statement, that is some men are mortal, some are not mortal, not like that. So if I am not specifically saying that all men are mortal, then this representation is okay. But if I am willing to specifically, clearly apply the identifiers, apply the quantifiers, then I must write in a way like this. Not writing this one, it will be much more better representation. That is, for all x, mortal. Okay. For all x, man x implies mortal x. Now any query? Now look at this statement. These two statements. Man is mortal. From that I may write mortal man. Now if I am writing for all x, if x is man, then x is mortal also. So that is a different representation with for all x, but much more clear representation and that is applicable for all x who are men. That is, all x who are men are modal also. That is, modality is there with each and every man. Now, any question up to this point? If you have any question, you may raise.
No, sir.
So that means, let me revise again. These were the existing operator in predicate propositional logic, and these two are the additional quantifiers in predicate logic. And why these are required? As I have shown you the one example, that is for all. That is for all x. This one is applicable. Similarly, there exists x also may be applied based on the given statement. Okay. So, just like if I'm taking an example, that is, students are good, or students of HETC are good. Now, if I'm saying students of HETC are good, so similarly, using implication symbol, you may write that is, if X is a student of HETC, then X is good. So, student of HETC within bracket X implies good X for all x. So that may be another representation using for all x. Now specifically, that is, if I'm saying in a statement, if I'm getting some, few, this type of word, let me write some, few. If you're getting this type of words, you always call this one. Okay, like some students are good. Okay, so how can I represent some students are good? I may write, there are some students, there exist some students which are being represented as with x. Now, if x is a student, that means they must be a student. The first property is x must be a student, then they are good. So there are students, or if the given statement is like this, that is some. Let me write this one first. Students are good. Some students are good. This one is my given statement. Now, if I am willing to represent it using predicate representation, then I may go for this one. And if I am specifically that is narrating this one, then that will not be similar to this one. Some students are good. So what I may say, there exists some student, there exists x who are students, and those x's are good also, or those x's are good. Or there exists some x, if x's are students, then x's are good also. So that is not applicable for all students. Now, if I am representing only this one, student x, then good x, so that will not be the correct representation of this one. Just look at this one. If you are not using any quantifiers, or you may say that indirectly this means that for all x, if you are not using this one also. Student x is good x, that means if x is a student, then x is good. Not all students are good. But if you are not using for all x also, indirectly it's saying that for all x, student x is good x. So sometimes for all x, automatically it's by default for all is being taken. And to specify few or some, you have to use for all. You have to use there exist. So here also, let me recall this one again. That is, if I am saying man is mortal, so this one is sometimes being taken as the correct representation. Or in most of the cases, that is mortal man. No need to go for this type of representation until unless you have to go for more and more elaboration. Let me tell you again. That means man is mortal may be correctly represented by mortal man, not going for the second representation. That is okay. That is okay, or accepted by most of the people, or in most of the cases. But if you're writing student x arrow good x, that one is not the representation of some students are good. You must have to go for a quantifier, that is there exists. So there exists student x arrow good x. That one is the correct representation of this statement. Are you getting me or not? That is by default, in most of the cases, by default, the statements are for all type. until unless some few these type of terms are being in use. Okay, after this, any question? So I have shown you the example use of implication, that is implied symbol, arrow, unidirectional arrow, and existential quantifier. This one is called the existential quantifier, and this one is called the universal quantifier. Okay, both are called the quantifiers. This one is existential, and this one is universal. Now let me tell you another thing. In some books you will get for all x colon then the statement. In some books you will get books or materials for all x then within bracket the whole thing. Okay. So different conventions are there. Now, if you are not using anything, if you are only using that way, just like this one, that is not using any colon or bracket pair, then that is also okay. No problem. Now you may follow according to your choice. But at the time of writing in answer sheet or anywhere where you are using predicate notation, so you keep uniformity in your writing. So if you are not using colon for at a place that is there exists, then you are starting with the given by blank space here, not writing colon, bracket, all these things. Then keep the same convention in everywhere. That is some at some places you are writing colon, at some places you are writing bracket pair. Don't go for that one. But you may choose according to your choice which representation you want to follow. Okay. Now any question after this one? Any question? Okay, if not, then let me show you some examples of not, and or, as well as equivalence, that is bidirectional arrow, this one, and the first three. So let me show you. Now, friendship, now I am showing you this one, that is the equivalence. Now, friendship, the functionality is always bidirectional. I think all of you will agree. That is, if Ram is a friend of, say, Raja, then Raja is also a friend of Ram. Is it true or not? That is, friendship is always bidirectional. It cannot be unidirectional. Just like if I am taking this example. Okay. Now you can. What a key question? Any question or it's okay? Now you cannot put bidirectional arrow here. Just look at this one. Man x mortal x, it's okay. But everything which is mortal, all are man, that is not okay. That is, I cannot write mortal x arrow man x. Then the meaning will be, if we are going to the opposite reverse representation, that is, if you are going from predicate representation to the normal statement representation, English statement representation, then it will be that is all mortals are men. That is not true. There are different animals who are also mortal. Okay. So that means if this one and this one both are true, then I may write only man x, then bidirectional arrow, then or equivalent symbol, then mortal x, but that is not applicable here. So this one is not applicable, this statement, this one is not also applicable, but in case of friendship, this one is applicable. So let me show you. So I may say, that is, if I am saying that Ram is a friend of Raja, Ram, Raja, then friend. So friendship. So Ram is a friend of Raja. Similarly, I may say that friend Raja, comma Ram. Raja is also friend of Ram. So both are true. That is, from this one I may get this one, or from this one I may get this one. But if you are taking another example like Sean A, comma B, or any specific name, Sean, say maybe Rahul, and say Mitul. But you cannot say Sean, Mitul, comma Rahul. So these are contradictory. These two are contradictory. if this one is true, this cannot be true. If this one is true, this cannot be true. So any one of these two must be false. Both cannot be true at the same time. But here, both are true. So in predicate representation also we are getting that similarity, whether we are changing the order of the arguments or not. Then based on the order of the arguments, change in order of arguments, which is the predicate is being used, based on that, whether it is true or not, we may decide, or both are true or not. Okay, now let me show you that is equivalence. Example of equivalence. Example of equivalence might be that is okay, let me take an example. For all, or not giving for all. Similarly for sibling also. Like friend, I may take the example of sibling. That is x and y. If in between x and y there is a sibling relationship, then I may write sibling, then x comma y. Okay. Now I'm coming to this one. Exactly the use of operator, use of equivalence operator. Okay, you may give me an example. I may go for the representation. I cannot recall, I cannot remember. Are you having any one of you having any? Can you recall any statement that is which is equivalence type? No. Okay. Okay, let me take an example. Like, if someone is okay, I got it. Husband x comma y implies wife y comma x. Any question at this one? If x is the husband of y, then definitely y is the wife of x. Any question here? No question. Now, may I write this one? If you have any doubt, that is, if this one is true, may I say this one is also true? If you are not agree, then you may ask me. That is no sir, the second one cannot be true if the first one is true. Similarly, let me recall friendship. Friend, if x comma y, if x is a friend of y, I may say a friend y comma x, or I may say a friend x comma y, sorry, not comma, friend y comma x. If any doubt, ask me. Husband-wife relationship, or maybe friendship, or maybe sibling relationship. Have you got it or not? But this, if you have any doubt, then ask me. Otherwise, I'll go for the next example. And want to tell you something with respect to this one. Is it okay? Equivalence is okay. Okay, no response. So let me go to let me show you another thing. But I cannot say that is further x comma y if this implies Sean x comma y I'm sorry. y comma x. That is, if x is the father of y, if it is implying that y is the son of x. Now, first tell me, is it true always? First tell me, is the last statement true? If x is the father of y, then y is son of x. If it is not true, then when it will not be true? And if it is true, then also tell me, yes, it is true always. Are you getting me? The last one. That is father x comma y implies
স্যার ট্রুই তো হবে।
true. Father x comma y implies সমান y comma x. True হবে কি always? If y is female, if y is female, then y may be daughter also. So we don't know why.
Yes, sir.
We don't know who is y. But if I am specifically saying that x is the father of y, then I am assuming, not assuming, I am granting that definitely x is male, so x is the father, but I don't know who is y is male or female. Now y definitely, y may be son of y x, or y may be daughter of x. So what I want to say, that not only representation at the time of equivalence or implication, you have to take into consideration the meaning of the statement. You also have to take into consideration the not only meaning of the statement of the representational difference, you must have to take into consideration the realities. That is, not always think in a way like this f of xy. Just in mathematics, that is, you will not be always in mathematics. Or that means always we are using in predicate functional representation. That means we will always follow the mathematics. You must have to remember the meaning of the statement. You must have to check what you have represented. Is it correct from every angle, or is it generalized one? That is what the statement is telling. Exactly, the predicate representation is telling the same thing, or some loopholes are there. If there is a loophole, then that will not be a correct representation. So what I have covered today, that is the predicate representation and the difference between predicate and propositional representation. What I want to tell you, that is the very basic question first comes, that is there you may get a question in AI papers. There is some statements will be given, and based on that you have to form the predicate representation. So that is a very basic thing. That is whether you are able to correctly represent a statement or not. Now, which are the operators you need, that is whether it is and or not or some other things, then that you have to choose. And you have to check what you have represented that is correct from each and every corner of each and every point of view or not. Is there any loophole? Then again correct that particular statement. Okay, I have to add this one. I have to specify this one. Just like as I have told, that is man is mortal. If the statement is man is mortal, then mortal man is sufficient. But if the statement is, that is, every man is mortal. If I am adding every man is mortal, then you must have to go for all operator. Without using for all, you cannot say simply that mortal man. Since every, the term every, each, all. So as I have told you that some, few, if these terms are there in a statement, always remember to put existence of body fat, that is there exists. Similarly, if there is an all, every, each in a statement, specifically written there, those terms are specifically written in a statement, then they never forget to use for all operator. And never forget to take the help of variables. Okay, I forgotten to mention these a, x, y, all are variables. Siblings, in siblings also x, y variables. But these are the specific values. These are not the variables. Okay, Raja, Ram. So predicate representation may be a generalized one. Now, when it is generalized one, then that must be with the help of those two quantifiers and variables, as many as you require. And variables are normally written in small letter, x, y, and normally the ending letters, that is in a letter sequence A to Z, the ending letters, that is W, X, Y, Z. Okay, these are being used, not A, B, C, D. You may use A, B, C, D, but of everything you have to write in small letter. But the convention is you choose the ending letters, ending 5 to 6 or 10 letters, W, X, Y, P, Q, all those things. You may use variable names like x1, no problem. You may use variable names like x underscore 1. Just as you have learned variable naming convention in programming languages. Underscore is allowed, no spaces are allowed, no special characters are allowed. And what you have to remember, the ending letters and all in small letters. And in most of the constants, so you may take those are as constant. Ram, Raja, Ram, Rahul, Mitul, all are constant values. If you are comparing with variables, then those are normally being written in capital letters. And predicates we are using capital letters. In most of the cases, friend F is capital. RIEND you may write in small or capital. And one more thing I have forgotten to mention. Okay, I have to show some and or also, and or not. So I think implication is clear, equivalence is clear, for all there exist is clear. So let me tell you about and or not and function. Now, and means if I'm saying that is if I'm not showing each and everything on paper. I think you may guess whatever the representation. If Ram has got more than 60% in mathematics, and he has got, or if I'm generalizing it, if a student has got more than 60% in mathematics, and if a student has got more than 60% in English, then he is a good student. So what will be the representation? Anyone from you may tell me, and I may start writing. Again, I am telling the statement. If a student has got more than 60% in mathematics, and the student has got more than 60% in English, is a good student. So what will be the representation? So definitely implication is required, and then and is required, and operator. Then what should I write? Anyone from you may respond, or I have to write? Okay, let me start writing. So anyone, that means any student. So for all x, if x is a student, first of all, first criteria is x must be a student. If x has got more than 60%, so here the concept of function is coming. Now this is capital. This is the relational function, a relation name or a predicate name. And what I have told you, that is in predicate logic we are trying to fix the relationship or functionalities. But here there is a separate function is also there, or use of function is also there. So what I may say that use predicate for this one, that is student is a predicate, student is not a function, or student is a relation. Let me tell you again. So here student is a relation or student is a predicate, but function, you may separate function to represent for different purposes. Just like greater than. If I am using GT for greater than, that is your choice again. No specification, but G must be in small letter. Always function name is written with, function name begins with a small letter. Okay, that means GT, say greater than, now marks, so greater than, that is English marks. So marks in English, I'm assuming that ME, GT 60, that is if marks in English is greater than 60, okay. Now function always gives, sorry, take 1 minute. GT. This one. Marks in English. Let me represent in different way. And student X is a student, and marks of X, marks in English of X, comma 60 GT. Now look at this one. Sorry, GT, now G is in capital letter. Let me make it clear. GT or greater than or G. Student X, if X is a student, and first concentrate on this part. That is, if marks in English of x and 60, I have taken two parameters. That is, within these, which one is greater? If marks in English of x is greater than 60, and now this one is clear or not? This one, this portion is clear or not? If you have any question. Now here I have written m in small. As I was telling you that function name must be written in small letter. And what is let me first make you tell you the difference. What is the difference between function and a simple predicate? Predicate always returns true or false, and function always returns a value. So that is the basic difference. Again, I am telling you, predicate or relationship always returns true or false. Let me go to the previous examples, like this one. Friend Ram, Raja. It will return either true or false. That is, Ram is the friend of Raja or not. If it is true, then T. If it is not, then F. Okay. It will not return you any other values. But if I am saying MEX, so that means X, who is a student, and ME means marks in English of X. Now this that means M underscore E X is nothing but marks of E. Now that cannot be true or false. That will return a numeric value. That is not a true or false. This one is clear or not? First tell me. If you have any doubt, what I have tried to represent M underscore E using M underscore E within bracket X is nothing but marks in English of X. Now marks in English of X cannot be true or false. So that is a function. Now function must be represented with a small letter at the beginning. Function name always starts with small letter. Predicate name or relation name always starts with capital letter. Predicate name or relation name always predicate or relation always returns true or false value. Function always returns a specific value, numeric value or maybe string value, any other types of values, not true or false. Okay, so let me go to the example again. What was the question? If a student has got more than 60% in mathematics and the student has got more than 60% in English, is a good student. Now I have started with this one. Again I am telling you, for all x, student x, that means those are student, and marks obtained in English by x, comma 60, that means in between these two, marks obtained in English by x is greater than that of the 60 and greater than marks obtained in mathematics. That also again not a true or false value. M underscore M, marks obtained in mathematics x, comma 60. If it is greater than 60, GT is greater than, so if marks obtained in mathematics is greater than 60, then now you may definitely use, there are two ands. Okay, so no priority of, that is no separate operators are being used. One is and, one is not like that. So you may enclose the whole thing within pair of first bracket, or you may not. It will be better representation if you are enclosing with a first bracket, within a first bracket, implies, what it is implying? It's implied good x. That is x is good. Any question at this point? Already 1 + 1. Time is 1 + 1. Any question? Now if you don't have any question, let me convert it into OR or using OR. Now if I am putting OR here, just look at this point. If I am putting OR here, not putting an AND, if I am replacing AND by OR, what will be the meaning? If x is a student, or for all x who are student, if the student has got more than 60% in English or more than 60% in mathematics, is a good student. Agree or not? So that is an example using OR. First one was two AND operators, second one is and two OR operators. Now here also, if you are willing to specify that AND between this and this, sorry, AND or OR between this and this, so you may again use another pair of first bracket, no problem. So as much as first bracket you may use, just as you have used in C programming. Don't go for any other
আসলে
bracket.
চলে যাবে,
But
কি
in
আছে?
some books or materials, you may get third bracket, second bracket. They are also using. You may use, no problem. But first bracket is sufficient. That is, remember the pair. Remember the pair. How many brackets you are opening? You are closing the brackets at proper places. If you are placing the closing bracket at different place, then the meaning will be different. Total statement will be the total meaning of the statement will collapse, and everything will lost. Everything will be lost. That is, the meaning will be totally different. Okay. Now what else I have to show? I have shown you the example using this one. I have shown you the example of function. I told you difference between function and predicate. I told you about using the operator and or. And also in the earlier examples, I have shown you the example of implication, equivalence, for all there exist. So all the operators I have covered today. And also I have told you at the beginning as what is the difference between predicate and propositional representation. And also I have told you about the standard representational difference and what you have to remember when you are representing a statement in predicate. What are the things you have to remember? Representational, that is notational things like capital letter, small letter, bracket, all those things, as well as the inner meaning of the statement. It doesn't change it should not change the inner meaning of the given statement. If it is changing or violating the meaning of the statement, then it will not be a correct representation using predicate representation, using predicate logic. Okay, so let me stop it here.
আমি তো কিছু দেখতে পাচ্ছি।
If you have any question, you may raise. If you don't have any question, then you may leave. So may I stop? Someone has joined now, just 2 minutes or 1 minute ago. I don't know, you have entered in, you have entered wrongly or maybe intentionally now. And the next class is at 3 o'clock. Okay, have you any question? Otherwise, I will stop.
No, sir.
Okay, so we'll meet here again at 3 o'clock, and we'll start our first lab today. Okay, bye. So you may disconnect one by one.